Good day, everyone. In this lesson, we'll discuss the lens antenna and how lens antennas start invented. Firstly, we learn the history of antenna. Next, what is lens antenna? What are the types of lens antenna? The principles and the characteristics of lens antenna, how to construct and working it, and finally, the advantages and disadvantages of lens antenna is important to know. First I discuss is about the history of lens antenna. The first scientist who attempted to construct lens antenna is Heinrich Hertz, but he failed to construct it. Although he failed to construct it, he discovered radio waves, electromagnetic waves of longer wavelength. Early scientists thought of radio waves as a form of visible light. To test Maxwell's theory that light was electromagnetic waves, these researchers concentrated on duplicating classic optics experiments with short wavelength radio waves. Hertz first demonstrated refraction of 450 MHz radio waves using a 6-foot prism of pitch. These experiments, among others, confirmed that light and radio waves both consisted of electromagnetic waves predicted by Maxwell. The possibility of concentrating radio waves by focusing them into a beam like light waves interested many researchers of the time. The second scientist who attempted to construct lens antenna is Oliver Lodge and James L. Howard, but he also failed to construct. They attempted to refract 300 MHz or 1 meter waves with cylindrical lenses made of pitch, but failed to find a focusing effect because the apparatus was smaller than wavelength. In 1894, Lodge successfully focused 4 GHz or 7.5 cm microwaves with a 23 cm glass lens. The third scientist is Augustus Reghi, but he also failed to construct because his microwave experiments at the University of Bologna focused 12 GHz or 3 cm waves with 32 cm lenses of paraffin and sulfur. However, microwaves were limited to line of sight propagation and could not travel beyond the horizon, and the lower power microwave spark transmitters used had very short range. So the particular development of the radio after 1897 used much lower frequencies for which lens antennas are not suitable. The fourth scientist is R.K. Lundberg, but he also failed to construct. Although he failed, he invented the Lundberg lens. The low-power microwave spark transmitters used had short range, so the particular development of radio after 1897 used much lower frequencies. The development of modern lens antennas occurred during a great expansion of research into microwave technology around World War II to develop military radar. Finally, the fifth scientist who successfully construct the lens antenna is the Indian physicist Jagadish Chandra Bose. His landmark 6 to 60 GHz or 25 to 5 mm microwave experiments may have been the first to construct lens antennas. Using a 25 cm cylindrical sulfur lens in a guide wave to collimate the microwave beam from his spark oscillator, and patenting a receiving antenna consisting of a glass lens focusing microwaves on a galena crystal detector. The second I discuss is what is lens antenna, a type of antenna that is designed to collimate the incident divergent energy in order to convert it into plane waves using proper lens material. It is a microwave antenna that uses the principle of refraction utilized by the optical lens for light in order to re-radiate the received energy in the desired direction. Also, lens antennae have similarities to parabolic antennas and are used in similar application. In both, microwaves emitted by a small feed antenna are shaped by a large optical surface into the desired final beam shape. They are used less than parabolic antennas due to chromatic aberration and absorption of microwave power by the lens material, their greater weight and bulk, and difficult fabrication and mounting. They are used as collimating elements in high-gain microwave systems, such as satellite antennas, radio telescopes, and millimeter wave radar, and are mounted on the apertures of horn antennas to increase gain. The frequency range of usage of lens antenna starts at 1000 MHz, but its use is greater at 3000 MHz and above. It is to be noted here that in case of low frequency operations, the dimensions become very large, thus antenna arrangements become bulky. This is the reason these are suitable for very high frequency operation. Functions of lens antenna. First, it generates plane wavefront from spherical. Second, it forms incoming wavefront at its focus. It generates directional characteristics. It is used to collimate electromagnetic rays, and finally, it controls aperture illumination. Characteristics of lens antenna. Compared with common antennas, lens antennas have unique characteristics. First, the side and back lobes of the lens antenna are small and the pattern is better. Second, the lens antenna does not require high precision in manufacturing the lens, and thus manufacturing is relatively simple and convenient. However, the lens antenna also has its own shortcomings. First, the production efficiency is low. Second, it is difficult to construct, more complicated, and last, the cost is relatively high. There are two types of lens antenna. First, delay lens antenna or dielectric lens antenna. Second, fast lens antenna or E-plane metallic lens antenna. Delay lens antenna is a type of lens antenna that causes retardation in the traveling wavefronts due to the lens media. The reason behind that is due to the medium of the lens. The electrical path length is increased and the wave undergoes retardation. Following are the features of the electric lens or delay lens antenna. First, it is useful at higher frequency. It becomes heavy and bulky at frequency less than 3 GHz. It is made of polystyrene or lucite and polyethylene. These are two types of dielectric lens. First, non-metallic dielectric lens and metallic dielectric lens. Non-metallic, this type is similar to optical lens. It may be designed by ray analysis method of geometric optics. While metallic, this type is less heavy to non-metallic lens. It consists of discrete metal particles of microscopic size. Fast lens antenna. This type, the traveling wavefronts are speed up by the lens media. Due to the medium of the lens, the electrical path length gets decreased and the wavefronts get accelerated. Following are the features of metallic plate lens antenna. First, it is constructed for a high-power microwave zoom antenna. It is easiest to build, cheap, and integrate. Principle of lens antenna. A lens antenna in association with a primary feed antenna in transmitting mode. When the feed is kept at the focal point of the lens antenna, the diverging rays spherical wavefront are collimated, parallel rays forming a plane wavefront after their incidence on the lens and passing through it. Collimation occurs because of diffraction mechanism. While lens antenna in receiving mode, incoming parallel rays converge at the focal point after passing through the lens due to the refraction mechanism. This is an indication of the validity of the reciprocity theorem. Collimation is also possible if the lens has refractive index less than unity. Lens antenna are used in association with a point source ideally, but in practice, it is used with horn-like antennas. Construction and working of lens antenna. If a light source is assumed to be present at a focal point of a lens, which is at a focal point distance from the lens, then the rays get through the lens is collimated or parallel rays on the plane wave front. What we call the rays that pass through the center of the lens are less refracted than the rays that pass through the edges of the lens. All of the rays are sent in parallel in the plane wave front. This is called divergence. The same procedure gets reversed if a light beam is sent from right side to left of the same lens. Then the beam gets refracted and meets at a point called focal point, at a focal distance from the lens called convergence. The ray diagram represents the focal point and focal length from the source to the lens. The parallel rays obtained are also called as collimated rays. In the above figure, the source at the focal point at a focal distance from the lens gets collimated in the plane wave front. This phenomenon can reverse, which means the light, if sent from the left side, gets converged at the right side of the lens. It is because of this reciprocity the lens can be used as an antenna, as the same phenomenon helps in utilizing the same antenna for both transmission and reception. To achieve the focusing properties at higher frequencies, the refractive index should be less than unity. Whatever may be the refractive index, the purpose of the lens is strengthen the waveform. Based on this, the E-plane and H-plane lens are developed, which also delay or speed up the wavefront. What do you call the beam gets refracted and meets at a point called focal point at a focal distance of the lens? This is called convergence. There are 5 applications of lens antenna. First, use as wide lens antenna. Second, use for microwave frequency application. Third, lens antenna are commonly used above 1000 MHz. Next, it being a microwave device, is performed to be used above 3000 MHz and not below. And the last, that the electric lens antennas are frequency sensitive, thus this specific type is not used over wide frequency range. The last I discussed is about advantages and disadvantages of lens antenna. The advantages of lens antenna: first, low noise. It is used for very high frequency application. Unlike the parabolic reflector in the lens antenna, the aperture of the lens is not obstructed by the feed point. And the last, it offers more flexibility in design tolerance. This means twisting in a lens antenna is possible. This is due to the reason that wave incident at one side and merge from another. While the disadvantages of lens antenna are the low frequency use of lens antenna makes the antenna arrangement heavy and bulky. Second, These antennae are more expensive than reflector antenna for the same gain and bandwidth. Summary of lens antenna. The scientist who construct lens antenna is Indian physicist Jagadish Chandra Bose. What is lens antenna? Lens antenna is a type of antenna that is designed to collimate the incident divergent energy in order to convert it into plane wave using proper lens method. The frequency range of usage of lens antenna starts at 1000 MHz, but it is greater at 3000 MHz and above. The two types of lens antenna are delay lens antenna or dielectric lens antenna, and second, fast lens antenna or E-metallic plane lens antenna. Characteristics of lens antenna. Principles of lens antenna have two modes. First, transmitting mode and receiving mode. What are the two types of lens antenna? The two types of lens antenna is delay lens antenna or dielectric lens antenna. Second, fast lens antenna or E-metallic plane lens antenna. Construction and working of lens antenna, and the last, advantages and disadvantages of lens antenna. That's all. Thank you and God bless. Stay safe.